Welcome to today's podcast. I am Sadia Anwar, Acquisition Editor at River Publishers. We are here to talk about our exciting new rapid series launch, Intelligence in Chips. Joining me are Professor Alex James, Dean Academic at Digital University, Kerala, and Editor in Chief of the series, and Ms. Rupal Jain, author of the series' first forthcoming book, Advancement in AI and IoT for Chip Manufacturing and Defect Prevention. Ms. Jain holds an MS in Electrical Electronics Engineering, accomplished leader and innovator in the semiconductor, chip engineering, and electronics industry, with managing global team around the world, specifically in Singapore, Taiwan, India, Malaysia, and USA. Thank you for joining me with this podcast. Let's dive right in. First, I would like to ask Professor James. The Intelligence in Chips series is a fascinating and forward looking initiative. What inspired you to establish this series, and could you share the primary goals and vision behind it?
Thank you, Sadia. The whole idea of intelligence in chip was to cover like a broad spectrum of this growing field. And if you look at the history of the chip industry, they started off with microprocessor as one of the major change, and then from the very start of computing, you could see people getting inspired by brain and being able to mimic the idea of computing in brain in various ways. And in fact, even if you look back into the history of microprocessor, you will see the bits and pieces of it. And today, what we see is with the advancements of neuroscience, understanding of the brain growing much bigger, we can see very much a lot of practical realization of even small bits of neural networks translating to LLMs and other things which are growing a lot of popularity. Uh, some of the things that bring out of that is the energy consumption of many of these computing paradigms, um, and implementation seems to be very, very high, and it's not comparable to that of human brain. And if we are to truly build intelligent systems, then the only way that is possible is to put that on to chip, or various form. It could be silicon, it could be non-silicon, it could be all sort of different types of hardware that we may be thinking about in the future. So the whole series is to cover the broad spectrum of this emerging area. Like, how do we take the idea of intelligence, at the end of the day, create systems which are really being able to compete with biological intelligence in form factors as well as in the idea of intelligence itself.
Thank you for sharing that. It's clear that this series is deeply rooted in advancing knowledge and innovation in the field. Now, I would like to ask you what makes this series stand out compared to others in the same field? Are there specific, unique contributions in this series offers to researchers and professionals working with integrated chips and sensors?
It's good that you said sensors as well, right? If you think about brain, the best form of intelligence that we know, large part of that idea of learning happens through those sensing mechanisms which are integrated deeply into those neural networks. So whether it's a sense of touch or what you see to everything, all the seven sensors, or beyond, we can think of all sort of things. Intelligence is often mixed with idea of sensing. So through this series, the unique thing is we are talking about all these things from a hardware perspective. So it's not just a real-time algorithm or even data processing. We are looking at systems, living systems at the end of the day, machines which could act and behave like humans. And if you were to achieve that, then the obvious way to go about is to build hardware, and this makes the series very unique compared to like a lot of other series and that you would find.
That's really interesting, and I appreciate how this series is addressing gaps in the field and offering something truly unique for the community. Now, with that, I will move towards Ms. Rupal Jain. Ms. Jain, your forthcoming book, Advancement in AI and IoT for Chip Manufacturing and Defect Prevention, explores groundbreaking technologies. Could you share some key insights from your book? How does it address the evolving demands of computing and sensor systems?
Yeah, so that's a really nice question, Sadia. First of all, I would like to thank you for the very kind introduction. I'm very happy to be here, being a part of Intelligence and Chip series podcast. And I would say that the book itself is a very comprehensive material because from all the feedbacks that I've received from my mentees and my peers all around the globe, I would say that there is a need for a comprehensive material which kind of addresses the need for knowing about the overview of semiconductor processes and also about the overview of semiconductor manufacturing concepts. Not just this, but also about the practical insights on how exactly defects originate and what are the mechanisms to control it. So having said that, I would say that manufacturing a SoC is not just applicable for computing and sensor systems, but for many other applications like space electronics, like aviation, like automotive, and so many other things, right? So I would say that the book is a very comprehensive material to cover all those aspects. Apart from that, it also gives policymakers, interdisciplinary researchers, students at all levels, engineers at all levels, and also I would say investors, VCs, or educators, an idea about the implications of the advancements that are going on, the integration of AI and IoT with respect to chip manufacturing and defect prevention, and also about the overview as well. So I guess that answers your question.
Thank you for that detailed overview. It sounds like your book is tackling some of the most pressing challenges in the industry today. Following that, what inspired you to write such a forward-looking book, especially when government initiatives are placing a strong focus on chip manufacturing? How do you see this book empowering students, industry professionals, and policymakers alike?
Yes. So now I guess we're hearing a lot of buzzwords around AI, IoT, but those are not just buzzwords. They're also transforming the kind of life we live in. They are impacting every other application. So to answer your question, the book is definitely giving an overview about the implications of these advancements, and thus it would be a good reference for policymakers, for educators, for engineers, everybody to understand what is happening in the semiconductor and the chip engineering world. And to answer the first part of your question, yes, there are a lot of engineering initiatives which are put forward by government, like the Chips Act in the US here, and the Semicon Mission in India, or the Silicon Catalyst in UK. So lots of these revolve around the concept of domestic manufacturing for chips, and thus the book fits well in the scenario. Being a comprehensive material and also a part of River Rapids, I would say that the book doesn't get too overwhelming with the concepts of semiconductor manufacturing and intelligence in chips, but also it would be a good reference material to just get an overview and also understand in deeper perspectives. Like the case studies brought together in the book would give you an understanding about the industrial insights, about the different practical scenarios that are happening in the industry. So those might be hypothetical, but those are real practical studies which could be helpful for not just students but also engineers. And also interdisciplinary researchers, like maybe if somebody's involved in material science, if somebody's involved in some other area of research like photonics, like Professor Alex said, like maybe some computing systems or sensor systems, then everything integrated together, the book is a helpful resource for everybody, I guess.
That's such an inspiring perspective. Your book is a valuable addition in this series, and it seems like it will make a significant impact on both the academic and professional communities.
Thank you.
Thank you for that. And now I will move towards Professor James again. Professor James, with rapid advancements in AI and sensors integration, how do you foresee the evolution of intelligent chip systems? What societal changes might these technologies drive, and how do you see the intelligence in chip series influencing this future?
Yeah, when you look about this area, like uh, we are moving from the idea of like intelligent devices to build chips to build systems. And today, like many of the systems can be packed into a chip as well, right? So the complexity that one could handle 10 years back or 20 years back is very different when you look at the chips today. So various kind of technologies go in, and what we are anticipating is more of 3D integration going in, more of chiplets going in. We would be seeing in systems of systems being built. So things that we see today, like in huge servers, eventually we would want to put that the form factors to be as small as possible. So the idea that we have today IoT, material science, to all these kind of things, they are going towards a convergence. When you think about like these systems to be built on a chip, then you are looking at like innovations in all these different aspects, whether it is coming from new kind of materials being explored, like including for packaging to interconnects to to new type of devices, all forms of CMOS integration to emerging devices to go in. All of these requires a large interdisciplinary effort. And once you have that, then the next thing is we are looking at like a society which should have devices which should probably speak human language at the end of the day, right? So they, whether you're going to banking, your bank may be in your hand at the end of the day. The amount of computing eventually that you would have access to is going to be in a very, very different way. Policies would change. The way the societies interact, like human computer interaction, would change significantly. How humans and humans are interacting also would change. So there is a whole another field that people look at called super intelligence. People talk about like beyond AI, AGI, and all those things. But in fact, many of these things are one and same that people are trying to attempt, like they're trying to create like intelligence in its original form. And if you are going to achieve it, then the next thing is, can you achieve more? So that is a question and debate. And obviously, when intelligence goes beyond a form of intelligence, the we will not be able to detect and say that that is a higher form. So that's another set of challenges we may be looking at for the future. So my feeling is that overall this series is going to stay for long because this is a problem and is evolving area which would have like a variety of problems to be addressed as we go along, both from a technological perspective as well as policy and societal perspective, as we see in another 5 to 10 years, I suppose.
That's a visionary outlook. The influence of intelligent chip systems on society sounds transformative. Aligning with that, how do you plan to engage younger researchers and innovators with the topics explored in this series? Are there any specific strategies or collaboration you are considering to keep the series relevant for the next generation?
Yeah, so we want to bring in like specific topics which would give very broad perspective on the area. We would also like to see technically strong things also to come in. So it's going to be a mix of books which would address like all sort of different problems and areas which are going to come up in this. So these days, like there is no shortage of information, right? Like people get access to. But then collectively as a series, can we bring in a lot of these topics to the new generation of scientists and to students to get introduced to these area, I think is one of the main thought behind this. So it's not going to be like one topic and we just focus on that, but we're looking to attempt and see this problem from all different angles, and bring in like people from variety of fields to engage in that discussion and see a way forward.
Thank you for sharing your strategies. It's great to see a focus on keeping this series dynamic and inclusive for new generation of researchers. Finally, what advice would you offer to professionals or researchers who might want to contribute to this series? Are there any particular emerging topics or trends you are hoping to see explored in future contributions?
Yeah, we are looking at like all sort of areas to cover, including devices, materials. I think one of the next book is going to be on materials focus, material science, and we are also looking at software, hardware co-design to come in. We are looking at like things which are related to policy to come in as well. At some point in time, to go in depth on semiconductor is going big. So how is it going to influence like this particular area? So uh, it's a good start with Rupal's like book, and we're going to see like evolution from that to different areas, and I hope like people can come in like and contribute to that.
That's valuable advice for anyone looking to contribute to this series. Thank you for sharing such thoughtful insights. I would like to say my sincere thank you to Professor Alex James and Ms. Rupal Jain for joining us today. And I wish you a great success for the launch of the series and the goals for your futures. Take care and goodbye.
Goodbye.
Thank
Thank
you.
you.
Goodbye. Thank you.